So, good morning everyone. So, today I will solve simple uniform bar problem by using ANSYS software. So, we already solved by using theoretical one. Okay, the same problem I am solving using ANSYS software. So, let's see. So, what's the problem is what it says. The figure shows a one-dimensional bar subjected to an axial loading. Taking it as a single bar element, determine the nodal displacement, stresses in each element, and reaction at the support. Now here also in generally when we solve any theoretical problems we have to follow some FEA steps. So for if when we using the ANSYS software, so there are only three steps. One is preprocessor, solution, and post-processor. So in preprocessor is generally called modeling process where we need to model the our geometry. Okay, then you need to apply your types of analysis, then loads and solution in the solution. Okay, then post processor you have to view your result. Fine, let's see how. So before proceeding process with first problem, first change the job name as this experiment one, right, as experiment one. Save. Okay, then go to once again file. You can change the directory where you want to save. Okay, now change the title. Now I am solving uniform bar. So here you write uniform bar problem. Okay, now say okay. Now when you scroll it, so here you can see that at the bottom left side the name it will appear, that is uniform bar problem. Now, so this is our first setup. Next, go to the preference. So this is our structural problem. So click on the structural, save. Okay. Okay. Then go to the preprocessor. Now I'm preparing my model. So this is nothing but your discretization process. Okay. So now we have to choose. So these are the options where we can choose the element type, area, material property, and modeling, meshing. Okay. So these all comes under your preprocessor. Then in solution, we have analysis type, define loads, and solve. And in general processor, we view the result, we can draw the graph, we can optimize or extract. Okay. Now let's see the start with preprocessor. So here we have to choose the element type. So right now we are solving by using 1D element. Okay. So here you can go to the add edit, say add, click on the link and say okay. Here you can see when I click on the link it shows 3D finite 180. Say okay, close. Okay, now in real constant generally we have to define the area, but after ANSYS 16 version, so they have changed the real constant tab into your more, that is section. Okay, so in before ANSYS 10 and ANSYS 11 the real constant it will give the area of the particular element. Okay, so now go to the material property. So now go to the material models. Now you have to assign your material property. Okay, so it's a structural, linear, elastic, isotropic. So just go to your problem, see what's the Young's modulus of this bar. So here the Young's modulus is 200 gigapascal. Okay, and Poisson ratio is, if it's not given also, you just take 0.3. Okay, so generally you have to look for the dimension also. So all the dimension in mm, so you have to convert this 200 gigapascal into mm. So what, how much you will get? 200 into 10 power of 3. So into 10 power of 3, how to write in this answer, you have to take e into 10 power of 3. Okay, so this is the way you have to write the Young's model or material model, or you can directly write 2 lakh, no problem. Okay, say okay. Now right now we have only one material and one element, so that's why we are construct only one element. Fine, now just close this, then go to the modeling. So you here you can model by using geometry as well as the measured element also. So right now here we can start with a measured element, that is nodes and element. So you just go to the nodes in active coordinate, just say first node, this is nothing but your origin node. Say 0 0 0. This 0 0 indicate x equal to 0, y equal to 0, z equal to 0. Say apply. Now just go to your problem, see what's the length of this bar. that is 1000 mm. So this is my first node and this is my second node. Okay, so right now I have created my first node. For second node you have to write as second node and x value is 1000. Say okay. Now to see this node, you just right click on your mouse and click on the fit. So you can see two nodes. Now we created the two nodes. Now next we need to create the elements by using these two nodes. So just go to the elements, click on the auto number, and in that through nodes. So just click first node, second node, and say OK. So it will create your element. So now this is nothing but your discretization project. So whatever we have the geometry we have converted into FE model. Okay. So here need not to mesh because we already use the meshed element. There is nodes and element. If we have the key points or lines, then you have to mesh. Okay, that will see when we are solving beam problem. Okay, that time we'll see all these things. Next, once we have this discretization or FEM model, next what you have to do, you have to apply the boundary condition. So here at first node it's a fix, and at the free end we have the forces. So just go to the solution tab. In that you just click on the analysis, new analysis. So it's a static. You just cross check that is the check should be marked on the static. Say OK. Then go to the define loads. Go to the set applied load. In that structural, in that displacement, click on the nodes and click on the first node because it's a constraint. So here in this problem the first node is nothing but it's a fixed one. Okay, so just click on the all degree of freedom, say okay. So now this first node or that is fixed end is totally fixed. Okay, the first node is totally fixed. Now at second node we have the force. So how much? It's a 10 kilonewton. Fine. So next you need to apply that force. For that what you have to do, you just go to the force, just click on the nodes and click on the second node, say OK. So it's a positive direction because it's towards right side. Okay, so just fx, how much? It's a 10 kilonewton. So just write 10. You can write e to the power 3 or 10,000 directly you can write. Okay, so this is 10,000. Say okay. If the force is acting towards left side, then you have to write as negative. So it will indicate the force is like a compressive. Okay, now if I write positive value, it's nothing but your tension. Okay, we just keep all these things in mind. Okay, when you solve any problem. Now you need to apply the area to this bar. How? You just go to the, so here in that section just go to the link and add. So this is my only one element and one material, just write as one material id. Okay, so what is the area of this bar? So 10 to the power of 4 mm raised to 4. So 10 to the power of 4. So 10 to the power of 4 is nothing but is 10,000. So okay, this is 10,000. Okay, see, okay. Now I apply the area. Now all the things I have, that is apply the material property, apply boundary conditions. Now what I have to do next? Next go to the solution, then go to the solve and solve this problem. Okay, click on the solve, so it will solve your problem. Say once it says solution is done, then your problem is solved. So to view the result, go to the general preprocessor, post processor, go to the read result. Sorry, not read result. Okay, you can go to the plot result also. So now I want to see my deformation. So here you can see what's the deformation, that is 0.005 mm. So just click on the deform shape only or deform undeformed shape, say okay. So here you can see you will get 0.005 mm. So whatever you solve the problem is correct. Just cross check your theoretical value with your analytical value. Okay, then you just look for your stress value, how much? 1 megapascal. Just go to the contour plot, nodal solution, element solution. So here you can see stress, go to the one mesh, say okay. So So instead of this plotting, you just go to the list results. So here you can get all the values: nodal solution, degree of solution, so displacement vector sum. Okay, here you can see you will get 0.005 your deformation, that is mm. Okay, then to get my element solution, just click on the element solution, stress, own mesh stress. Okay, here you can see 1 megapascal. Here 1 megapascal is nothing but 1 newton per mm square. Okay, for reaction solution, just click on the reaction solution, say all items, say okay. So what is minus 1000? Because why it's getting negative means, here we applied positive direction at the second node. So obviously at node 2, node 1 will be the opposite direction of with of about of with your second node. Okay, so here in this ANSYS you can also view 3D, uh, 3D view. Okay, you can also view the 3D. So just go to the plot control, style, mm, size and shape. Okay, so it does display the element. Okay, control. You can animate also here. See, more shapes. Okay, to view the 3D, to view the 3D, you just go to the plot control, click over the style, then click on the size and shape, click on the element, that is display of element, say okay. So here you can see, so this is your 3D view. So just click on the isometric view, you come to know it's a 3D view. Now to view the deformed and undeformed shade, go to the plot control, once again style, and style, just look for the, yeah, go to the animate, just look for the deformed shape. Okay, then here you can see you can view deformed shape only, or deform undeformed shape, or deform undeformed edges. So we just click on the deform plus undeformed. So here you can see, so now it's animating how much it's get deformed, this part. So it's a 0.005 mm. So this is nothing but your deformed value. Okay, so to stop this animation, just click on the close, so it will stop. Okay, then to go to your normal view, just click on the uh, yeah, so this is right view, left view. Okay, so just click on the front view, then once again you will need to remove this element, that is size and shape display element. Just click on the off, say okay. So, so like this you can solve all kind of problems, that is book bar, all kind of bar problems. Okay, thank you guys.